All right, let's go ahead and start our lesson now. We're doing 8.3 day 2. And on our last lesson, we learned how to find the volume of a sphere. We learned that a sphere, or like a ball, has a formula of 4/3 times pi times radius cubed. And that would give you how many cubes to fill up a sphere. But what we're dealing with today is half of a sphere, right? And sometimes you might use semi or hemi to mean half, like in different instances. But what you're used to, what things that we've heard before, like in science class, is a hemisphere. So we'll look at this half of a sphere and call it a hemisphere. We're going to find the volume of a hemisphere. So a hemisphere is the same as a sphere, except we want half of it. So you got two choices here. You can just pretend it's a sphere, and then when you're all done, hit divided by 2 in your calculator. Or you can just memorize this right now. If we cross out our ones here, and we take half of a sphere, then the new formula for us hemisphere volume is 2/3 pi r cubed. So let's see how you guys did. We'll take out our calculator here, and we'll go ahead and do our exponents first, and we probably should plug in a number that we need before we get our calculator. So 2/3 times pi. In the radius, we only need one measurement to find the volume of a sphere. Now I can get my calculator and I go 5 times 5 times 5 times pi. And then times, and how do we do 2/3? We do times 2 first, and then divide by 3. And we get 261 and 6 repeating, so rounded to the nearest tenths, that would be 261 and 7/10. What, though? I forgot my units of measure, right? What should I have put there? Remember, this is volume, so it's centimeters cubed. Now, of course, if you used your pi button on your calculator, this will be a little bit bigger, but it should be very close. Only one answer will work on the test if you're using your pi button. So let's go ahead and start our next problem. Oh, actually, you know what? I have to teach you something new today, something that you're going to see in algebra classes along with this year, and you're actually going to see throughout high school, and that is called in terms of pi. What does in terms of pi mean? So let's take a look. In terms of pi means you leave the pi in your answer, the symbol pi. So you don't estimate it. And when they say give your answer in terms of pi, they're actually asking you for an exact answer, right? Because if I asked you, hey, what's 2 times pi? And most of you could say, well, 2 times pi is going to be 2 times 3.14, right? Well, it's rounded because pi isn't exactly 3.14. So if you wanted to know exactly what 2 pi is, the only way you could write it was 2 pi. This is exactly what 2 pi is. So for example, you guys know that 2x, that means 2 times x, doesn't it? So 2 next to x means 2 times x. 2 next to pi means 2 times pi, and that's what in terms of pi means. That means you don't take out your calculator and hit the pi button or times 3.14. You just leave the pi there the same way you would leave an x. Okay, so that's something you learned today. So let's go ahead and let's do that last problem we did just a minute ago and see this time, instead of giving this estimated answer that we gave, let's give an exact answer. And by exact answer, they mean in terms of pi. So how would we do that? Well, we're going to do it very similarly to what we did last time. The formula for the volume of a hemisphere is, now it's half, so it's 2/3 instead of 4/3, right? 2 is half of 4. 2/3 pi r, which is still 5 this time, cubed. So now to get an exact answer, I don't even think of pi. I just go 5 times 5 times 5 again. Skip the pi for now. Times 2 equals, divide by 3. And we get 83.3 repeating. Remember, we're not going to round anything because they want exact. It's 83.3, but not really. It's 83.3 repeating times pi. So that's what in terms of pi means. We don't punch it in the calculator. We kind of treat it like an x, okay? So One answer could have been 253 and a third, or 83.3 repeating. And of course, if you guys had to convert this to either a mixed number or a fraction, you could write this part as a fraction and then convert by multiplying and adding. That's how we get the 250, right? Okay, so let's move on now. Let's try the next problem. Now that we have that new knowledge of what in terms of pi means, or an exact answer, when pi is involved, we do in terms of pi. So let's go ahead and try the next problem. I want you guys to pause the video, read this problem, and try this problem. So let's see how you guys did. So we need to give an exact answer. That means I'm going to have pi in there, right? For a sphere is 4/3 pi r cubed. Not to be confused with what we did a second ago, a hemisphere. So once they say sphere, they don't say hemisphere or even semisphere, right? I think that'd be the same thing. Then we have to use the 4, not the 2. It says give an exact answer if the radius is 12. So that means I do 4/3 times pi. I'm not going to write it as 3.14. I'll put my radius in there, and I need to cube that first in my calculator. So I grab my calculator. I go 12 times 12. And for a sphere, we got to do it a third time. Skip the pi for now because they want an exact answer. Times 4, divide by 3, and we got 2,304, but not really. It's 2,304 times pi. And the way you would read that is 2,304 pi miles cubed. That's the volume of that sphere. If you guys got that right, go ahead and take a look at this next problem. Pause the video now and try it. So let's see, how do we do this one? Look, they put the word hemisphere back in there, right? So now I'm kind of using this, but I'm using half of this, so I just do 2/3 pi r cubed. That's a hemisphere. So the radius is 12. Okay, so I go, it looks like the same problem, doesn't it? Take a look up here, you guys. Look at how, and you know I'm doing this on purpose, right, to make a point. It looks like 12 radius, right? Exact. And in terms of pi means exact, doesn't it? Same thing. So it looks like the same thing, but you know it's not going to be the same answer. Why is it not going to be the same answer? Because we only want half of it, okay? So again, like I said earlier, if you understand the concept that you can just do this and then divide by 2 in the end, great. I'm just going to stick with one way of doing it though. I'm going to say I'm going to use my new formula. 2/3 pi r cubed is the formula for the volume of a hemisphere. I'm going to leave pi in there because they say in terms of pi. And the radius they give me is 12. So the rest is done in my calculator. I get my calculator. And I would do 12 times 12 times 12 times 2 this time. Then divide by 3. And we should have got, is it 1,152? Answer is no. It's 1,152 pi, or times pi, right? This is, approximately 3 times bigger than 1,152. Now, those of you that are clever and you knew that a hemisphere is half of a sphere and I gave you the same measures, yeah, you could have just took this number and divided by 2. That would have gave you the same answer, right? But you won't always have that option, so I want to make sure you guys know what to do, what works every time. If you got it right, let's move on. If not, pause the video, try that again till you get it right. Otherwise, pause the video now, try this review problem. So let's take a look here. We have quotient of power, meaning a fraction is a division problem. And I'm dividing powers because I see like a variable with an exponent next to it, right? So that big part is called the base and exponent. Now just remember, this 3 is not to the -1 power. Only the x's. If you had parentheses like this, then they'd both be to the -1st power. So what this is 3 times x to the -1st. That's what 3 next to x to the -1st means. Okay, so just make sure we understand that. And down here, 4x squared means 4 times x squared. In other words, that 4 is not squared. Now, if it was written like this with parentheses, yes, then the 4 is squared and the x is squared, but here, only the x is squared. So basically, we have the fraction 3/4. And then we have this division problem where we have powers with the same base. So I copy my base and I subtract my exponents. I go the top exponent minus the bottom exponent. And I'm sorry about my sloppy writing there. I'm just trying not to make these videos too long for you. I go top exponent minus the bottom exponent. So I go add the opposite, and I have 3/4 x. Same team means add. Negatives have more. But I wasn't clear, was it? If I said simplify, nice writing. If I said simplify, then I would have to, you guys remember this from class, I hope? I would have to flip that negative exponent. I wouldn't flip this guy upside down because he's not to the negative power of anything, right? Only the x is because there's no parentheses. So the 3/4, what I'm trying to say is the 3/4 has to stay the same. Whoops, not 3/3. 3/4 has to stay the same. So the 4 is on the bottom, the 3 is on top. Right now, out to the side means on top, doesn't it? So if you have a negative exponent and you have to flip it, if it's on top, it's got to get flipped to the bottom. That's what a negative exponent means. It doesn't mean it's a negative number. It means you got to flip it upside down. That's what those negative exponents mean. So I flip it to the bottom, my exponent becomes positive, and my answer should be, simplified, 3/4x cubed. Whenever dealing with fractions, just make everything a fraction. Okay, so -8/5 is already a fraction. Remember what I said? Put the negative up top so you know what to do with it. 2 2/5 is not a fraction yet, so I start on the bottom. I multiply. 5 times 2 is 10. Then I add 10 plus 2 is 12. So I got 12/5 b. Over here, remember this whole thing is negative. It's not like this part's negative and this part's positive. Don't think that way. The whole thing is one big negative number. But when we're dealing with fractions, right, so we know what to do with it, we just put the negative up top. Okay, so the negative's up top. Now, like I did over here, convert. 25 times 10 is 250, plus 6 is 256. Keep the same bottom number, and that means that -256 is the same number as -10 and 6/25. So all I did is I made my mixed numbers into a fraction, because anytime I'm dealing with fractions, just make everything a fraction, right? Okay, now we can solve this. We're going to isolate the variable. The variable's here. We work farthest away from the variable first. This is farthest away, so I do the opposite of -8/5, and that is to add +8/5 to both sides. And that's how we get rid of this on this side. And what we have left on the left side is 12/5. Remember, 12/5 is the same as this number here, right? 12/5b equals, I got to add these two together. So let's relearn or review if you learned it the first time. First however many times. I know you guys keep seeing fractions over and over again, right? How to add fractions. We have to have the same bottom number. So we look at the multiples. Multiple means multiply, right? Multiples of these. 25 times 1, 25 times 2, 5 times 1, 5 times 2, 5 times 3. The first time they'll be the same, or the lowest common denominator, denominator means bottom number, is 25. So I rewrite these fractions so that they have 25 on the bottom. This one already had a 25 on the bottom. I don't need to multiply it by 1/1. Now this one over here, if I multiply the top and the bottom by the same exact number, then it's still 8/5 is the same as 40/25. Still the same number. It's just one number is reduced and the other one's not, but it's the same value because I did the same thing to the top and the bottom. So now that I've figured out a way that I can do this step up here where I add these two, I have the same size pieces or common denominator. I can add my numerators. I have -256 over here, +40. And in this part here, I don't mind that you use a calculator, but I wouldn't want you to use a calculator, convert this to a fraction, convert this to a fraction, and do it that way. That's kind of cheating here because the skill you're practicing is how to deal with fractions really without a calculator. And your answer is going to be, have to be a mixed number or a fraction anyway. So, I mean, unless you know how to convert that in your calculator back and forth, These are the skills we're trying to learn for Algebra 1 next year and Algebra 2 also later on, a couple years, okay? All right, so opposite teams means I subtract these two. So I go 256, take away 40. I have a difference of 216, and I have more negatives. So I got negative 216 over 25. This is where I'm at now. I'm on this line. I have to get rid of that 12/5. That's a 5, not an 8. So what do I do to both sides? When I got a fraction in front, I flip it upside down or use the reciprocal or what's called the multiplicative inverse, and I multiply both sides by that number. So the fraction in front, I flip it upside down, and I multiply both sides by that number. So here's what we had before, and we had this on this side over here. Notice I'm using parentheses, so it's not a subtraction problem, it's a multiplication problem. And let me squeeze down here. Okay, this is gone. I have b equals, now we're going to cross cancel, right? I do factor trees, cross out my 1. 5 goes into that, 5 goes into that. This is going to be 5 times 5, cross out my 1s. Over here, 216, just to show you real quick to save time. I don't need to reteach you factor trees, I hope. 216 and 12 is going to go into it evenly, I think. 216 divided by 12. Nope, it didn't. 216 divided by 12. Yep, it did. Okay, so when I do my factor trees, cross out my 1s, I'm going to end up with an 18 up there. I get negative 18/5. And notice we didn't get that answer, so that means I have to convert. I go in and out. I divide, top goes in, bottom goes out. 5 times 3 is 18. 5 times 3 is 15. Subtract to get a 3, and you see where we get the 3 3/5, and the sign was negative, so that's how we do it. A lot of work, I know. Guys, look at all that work. But it's really to your advantage for high school that you guys are solid with fractions, so that's why I'm doing that to you guys. Let's keep practicing that, okay? All right, let's go ahead and pause the video, try the next problem. Solving multi-step equations, what we do is simplify both sides first, keep my variables on the same side second, and then isolate the variable third. So let's do that. Let's go ahead and do the rule for subtraction, add the opposite here. And the left side is already simplified, and the right side I'm going to distribute. I get negative 5v plus negative times negative is positive. 5 times 2 is 10. So I distributed that 5. Notice that this became a 10. It's still not a 2. So I'm still simplifying the right side. The left side was already simplified. The right side I had to distribute, but now I have to combine like terms. Negative 5v and 7v is 2v. Opposite team subtract. Positives have more. Now we get our variables on the same side. When we move our variables on the same side, this is when we start doing inverse operations, right? I don't do opposite until this step 2 starts. So I take the v with it because I only want v's on one side. Otherwise, how can I isolate a v if there's more than one v? Now that there's only one v on one side, I can isolate by working farthest away from the variable. Again, in these two steps, steps 2 and 3, we're doing inverse or opposite operations. We didn't do that up here in step 1 when we were simplifying. So I have 3v equals, those are opposite teams, subtract. Negatives have more. Cross out your 1s. And it looks like the answer that makes, the number that makes this equation true up here is negative 1. We're going to go ahead and try to solve this system now. This is actual review, but there's something that's new. This system right here doesn't have one of the equations where there's a missing coefficient and it's easy to avoid a fraction. We can't. And you're going to learn next year in Algebra 1 that sometimes it's easier to use something called the elimination method. Sometimes it's set up for that. But we didn't learn that. So what my point for this problem here is that even though it's set up for the elimination method, we might have to deal with fractions, you can still use the substitution method to solve it. So this is a problem where it would be smarter to use the elimination method, but we haven't learned it yet, and we're still going to be able to solve it by using what we learned in 8th grade. The substitution method for solving a system of equations. Now, sometimes you can look at this and see which one of these should I isolate. Sometimes you can avoid a fraction. Sometimes they're unavoidable. And unfortunately, this is one of those times. So I'm just going to pick one of the equations. I'll pick the top one. And I'm just going to pick one of the variables to isolate. I guess just y. So I'll go ahead and subtract 2x from both sides. It's kind of like putting in slope-intercept form, right? And remember, you can't combine the x with the 6 because the 6 doesn't have an x, right? So I want to still isolate the y. So remember, when you divide everything, divide everything, right? It's like you put a line under everything. So I got negative 2/3 x plus 6 divided by 3 is 2. So unfortunately, I still have a fraction, but that's all right. We can deal with that. Now I'm going to plug this into the other equation where the y goes. So I'm going to rewrite that. I'm going to go 7x plus, and then it says 3y. Well, y equals all this stuff. So I'm going to put this stuff in parentheses using, this is the first substitution. We're going to substitute the y. And then don't forget to write the rest of the equation. Equals -9. Okay, let me go down here. So now we're going to solve a multi-step equation. We simplify both sides first. 7x is on the outside. I distribute the 3. Don't try to add that 7 and the 3, right? I have to distribute before I combine like terms. Now watch what happens. My 3's cross out, and I get -2x. But don't forget, you got to multiply the 3. Let me do this over here. You got to distribute this 3 into this 2 also right here, right? You got to distribute that as well. Okay, let me make sure I'm back on the right thing here. Okay, so over here, I'm not going to write a 2. I'm going to write 3 times 2, which is 6. So I combine my like terms. And then I continue to solve this equation. Whoops. Oh, there's my mistake. What did I do wrong there? So I had a -9 up here. I think I thought that was a 5. I had a -9 up here. Did you guys catch my mistake? And then I subtracted 6. I should have got -15. I was like, what did I do wrong? Then I divide by the coefficient. And 15 divided by 5 is 3. Negative divided by positive is negative. So notice that my x is a -3 there, isn't it? Okay, that's how I get the -3. Now, how do I get this 4? I can take either one of these two equations and plug that x in where the x goes. Okay, let me erase all this over here. I know what x is now, and I can plug it here and solve for y, or put it here and solve for y. But you know what? Earlier, I had done this. I took that top equation. Let me go ahead and get my highlighter here, if I can make it work. It's not going to work for me. How about pointer? There we go. It's a little slow, sorry. So this I rewrote as right here. I rewrote it where the y was already isolated. So I have y equals -2/3 x. Come on, marker. -2/3 x plus 2. That's this equation here. I just move the 2x to the other side, divided by 3. So what I'm going to do instead, I'm going to take my x and plug it into the equation where y is already isolated. In other words, I'm going to put that right there where the x goes, because it's x, right? Over here, if I were to finish this, I ran out of space, x equals -3. So I can put that here where the x goes. To get my y is, or my y equals, -2/3 times my x is -3, where these lines intersect are at the solution, and that's a sloppy 2 plus 2. Make this into a fraction. Cross out your 1's. Negative times negative is positive. And now you can see where we get the y value of 4. So the solution for this system is -3/4. So, long story short, if you guys are going to solve using the substitution method, you got to pick one of the letters and isolate it and plug it in to the other equation where it goes. Get one of those answers, plug that back in, and get the other answer, and that's where these two lines intersect, or that's the solution to the system. Okay? Try to avoid fractions if you can, but if you can't, You guys can handle it. We'll just keep practicing those fractions. Don't want to let that skill go. Pause the video now. Try this next problem. So writing the equation for a line, if it's a line, I know it can be written with a slope-intercept form. If I know the y-intercept, that number goes here. And if I know the slope, I'll pick 2 points that are that have integer coordinates. That means they're not like fractions. They're where the lines intersect on this lattice here. Okay? Right on the lattice itself. And I see to get from one point to another, I have to go down 1, 2, 3, 4, 5. I went down 6, and I went over 1. Down 6 to the right 1 is a slope of -6. And slope goes here. Y-intercept, where it hits the y-axis, goes here. And that's it. That's how you write the equation for that one. Almost done, guys. Hang in there. And it looks like, whoops, looks like we got the last one here. Go ahead and pause the video. Try the last review problem. So we have a right triangle here. That means Pythagorean theorem. And I have to decide, am I missing a leg or hypotenuse? I have the long side, so that means I'm missing a leg. So I can say a squared plus, this has to be the other leg, b squared equals, the long side has to be by itself. If I didn't have the long side, I'd put a letter there. But since I have it, I put a number there. And from here, I don't mind if you whip out your calculators. 84 squared is 84 times 84. And I got 7,056. 7,056 is 84 squared. What about 85 squared? Let's find out what that is. Clear this out. I go 85 times 85. Whoops. Whoa, Nelly. Let me pull my lesson back up here. Okay, so I'll go 85 times 85. And I get 7,225. 7,225. And we'll go ahead and subtract these two. That's already my calculator, so it minus 7056. And I get a difference of 169. A squared is 169. But I need a, right? This is what this square is. I want to know what just one side is, so I take the square root of both sides. That makes a squared become a, but the square root of 169 is 13. And you can just, in your calculator, you would have 169. You would just hit the square root button, right? Just like that. Okay, and then we get our answer. All right, guys. We'll see you next week. Let me figure out how to pause this here.